So today you're going to focus on some really good note taking. Look to be organized, look to skip lines. I'm going to show you my notes on the dot cam after each section, after we go on to here. Just to show, as you get older, the note's going to be more important. Research shows, if you write it down, you remember it better. You can say, no, it doesn't, but that's what research says. Additionally, research also says you can look back at notes if you take them. That's a joke. You don't need research. That's common sense. If you take notes, you can reference them. If you don't take notes, you cannot reference them. And I'll let you know from experience, there's a lot of times, even in math class, as a person with pretty good math grades and pretty good aptitude, there were increasingly more and more times as I got older that I wanted to look back at notes. Sometimes I'd be like, nailed it, and I'd get home and be like, what did I do? And I needed those notes to look back, even though in the moment I felt solid. So that's going to be one of the focuses today, because I don't think the math is going to be an intense challenge. We're going to start with these solar cells. We're looking at 77 to 87 in our context here. What does everybody notice about the price of electricity using solar from 77 to 87? What happened?
It's going down.
It's going down. It's yelling timber. And the reason for that is that's pretty common with lots of technologies. The thing I always go to is 20 years ago, my parents bought this fancy projector TV thing. It wasn't a tube. It was like a little projector all in one box. And it was like $2,500. And my TV I have now is bigger and better and much smaller, and it costs like $250. Okay? As most things have increased in price. So technology usually gets better and cheaper. That's what's happening.
Bigger, better.
Well, bigger screen, narrower by volume. Okay. Yep. So what you're going to do is you're going to look at these solar cells and the situation and say what's happening when. Take good notes. Get organized. Label things. Skip some lines to stay organized. So squiggly is about. It means like about, roughly. Because if you look at that graph, can you tell exactly what things are? No. If it was off by like pennies, would you know? No. All right. Get after it with your partner. Be organized. All right, y'all. So who can tell me what f of 9 is about 6 means in context? What does that mean? Will Baker.
9 years after 1977, the cost of
Is how much?
The cost of 1 watt of solar power was about $6.
Yeah. And we've got that right here. About 9 years after, right here. 9 goes in, 6 comes out. What is f of 4? Who can tell me what f of 4 is? Finn?
25.
25, so I'm going to just write that here, 425. And that means 4 years after, it's $25. What about 3.5 years? Who's got that one for me? Raymer.
29.
So 3.5 right here. It's about 29. Okay. And remember, that's years after 1977. Did anybody put the actual year like 1980 and a half or something like that? That's something you could like give the year as well. All right. When was it $45 per watt? Who can tell me that? When was it 45? Eliana?
2 years after 1977.
Yeah, so one way we could write that is f of 2 is 45. You could also write when t equals 2. That means 2 years after 1977 or 1979, it cost $45 per kilowatt hour.
Why
So,
would it cost more and
because the technology wasn't good.
Oh, so this is more than one solar panel.
So this is how technology works. It's kind of crazy. Like the prices end up being cheaper even though everything costs more because the manufacturing gets better. Like when they make the first, let's say, when they made the first LED TV, it's like all the components are like one-off, right? The first of that. There's not like this big system set up to make them. Well, after they make some TVs for a few years and there's the system to make all the components, all the parts get cheaper, people get better at making it. Technology is the one thing that over time, in general, will get cheaper. So they're probably better at making solar panels as time goes on, right? And if they get good enough, it gets cheap enough, we probably ditch other means of energy. Right? But right now, it still costs more than other means of energy, so that's why we stick to it.
My uncle is actually like one of the top like salesmen for solar panels.
Sweet. Michigan's not the best place for it, but What factor did it change? So I like looking at these 2 years, year 0 and year 1. So did the price go up or down, first of all? Down. And so there's 2 ways to look at this. By what's left or how much we lost. I like to look at what's left because then I don't have to do anything else. So how much is left after 1 year? 3/4. Or I see 60 out of 80, which is 3/4. Another way to look at it is I lost 20 out of the 80, and a loss of 1/4 leaves 3/4. So there's 2 ways to look at that as options, all right? We all good with these solar panels? I like this. This must be Midwest though, right? Does that look like some fall colors popping off? Right here?
It looks like there's a trail map too. Down.
Oh, like at a park with a trail map. That looks nice. Get back up. We're gonna. There's 2 different paper folding contexts here that you're gonna work with your partner. The first one is the thickness of your paper. What happens to the thickness of your paper every time you fold it? Yeah, well, it doubles. Okay. The next one is the area of your paper. When you fold it in half, what happens to the area of your paper? Half. So you're looking at 2 different things with the same context, kind of. There is going to be a decimals portion. Be ready for that. This doesn't need anything else. You're going to be able to get after this with your partner. Again, focus on good notes. So checking out this piece of paper. Who can tell me what the 0.05 represents in our context? What is it, Finn?
The original thickness of the paper.
Yeah, it's the thickness, right? Which means we're starting at 0.05 millimeters thick, or kind of thin, actually, right? Then, that's right here for thickness. Then you graphed it in decimals, typing it just like that, except with X's and Y's probably. How many folds did it take you to get to 1 millimeter?
5.
It took 5 folds? Yeah, it was like 4 point something, right?
Yep.
So 5 folds to get 1 millimeter. What about to get to 1 centimeter? 8 folds, or more than 1 centimeter, right? So let's go look at the decimals for those 2 things real quick. Okay, so here's our function. I want an output of 1, which is between 4 and 5. That's my 5th fold. Would this be a continuous or discrete situation in general? For number of discrete, right? There's only whole folds. And then 1 centimeter is 10 millimeters, right? So that happens. 7 wasn't enough. Must be 8, as you said. Good work, y'all. Let's go back here. Now we're down to area. So area is different. Instead of doubling in thickness, area halves when we fold. So if it's asking me for once, twice, and 3 times, what's the thing that you might want to make? A table. Okay, so where did it start? 1 fold, what'd we get?
47.75.
Okay, 2 folds. 3 folds.
11.6.
And then make sure, like, let's say you wrote down something rounded here. I saw this on the checkpoint the other day. You need to keep the whole number in your calculator. Don't use the rounded number to do the next step. If you're like doing times something. Because if you keep multiplying by a rounded number over and over, what's going to happen to your answer, do you think?
It's gonna change.
It's going to get further and further away from the actual. So you can write the rounded number, but keep the whole number in the calculator, okay? Next up, let's write the function. So we got to use the right variables. Visible area A. What was my starting area?
93.5.
Okay, thanks. What's happening to it, everybody?
Cut in half.
Cut in half. How many times?
1.
N times. N times. Okay. I don't need to look at the graph. Can N, or the number of folds, can we have negative folds? No. No negative folds. Can we have negative area? No. No negative area. Now notice decimals would give you a negative x value because decimals doesn't know what?
Context.
Decimals doesn't know context. It's just a tool, right? Technology is not smart.
Dumb.
It's dumb. It only does what people tell it to do. So you've got to understand the context when you use the tool, all right? If I go missing, that's because technology got smart and I just called it dumb, guys. So if I go missing, you know to look for chat GTP or whatever, okay?
What's that theory someone's basketball is?
I think that theory is called the Terminator. All right, we've got a lesson summary to do here. Homework's in the basket when you are done.